Ladies and gentlemen, this is Joe's Classic Video Games, back with another cool pinball repair video for you this evening. Check this one out. We have been working on this Gottlieb Close Encounters of the Third Kind System 1 pinball machine. Gottlieb was the king of electromechanical pinball machines, and they were reluctant to make solid-state games, but they finally did, and this was one of their very first ones, Close Encounters of the Third Kind, based on the movie. And this thing ain't working, because whenever they designed it, they had Rockwell design it, and Rockwell did them wrong, man. They did them wrong. They designed this board with all of these spider chips on it. I'll show you here in a second. And so on the previous video, we kind of just looked through the whole thing, and we worked with the power supply, got the power supply up and doing its thing. Did a couple little, replaced the capacitors, things like that. Whew. George is back, people. Some of y'all know what I'm talking about. We worked on the power supply. We now have all of the correct voltages going up to the board. It's getting a good 5.1 volts, and it's getting a good negative 12.1 volts, and it ain't doing nothing. It's dead. But part of it is it's got some battery leakage on it. Poor battery. It's got a data sentry on it, so we'll pull that off and check it out. But we need to do some MPU work. So I'm going to pull that board out, take it in the back. We'll look at it a little bit closer, clean up some of that damage, and then see if we can figure out why the thing's not booting. Okay, so here is the board, and here is the damage done by this battery. It's not that bad, really. There's a little bit over here and a little bit here. This is usually like the switch section. So when the thing comes up, if a switch is stuck on, it won't boot. If the slam switches aren't stuck on, it won't boot. So there's a bunch of little things that'll cause it not to boot up. So the front doesn't look that bad. Let's check out the back. This is very typical. See how corroded the pins are where the switches connect? You know. So it won't boot without a slam switch. It tests the slam switch in the cabinet, or I think a couple of them. And if they're open, it won't boot up. The slam switches, so if you kick the door, gong, the game will reset or whatever. So if that thing is open, it's in basically a reset mode or whatever, right? So we got to clean that up. That ain't good. Look at that. So I'll wipe that down a little bit. What I use is a little bit of sandpaper. Get it nice and shiny again. And then you can actually take a little bit of vinegar and put on it to neutralize it. And then wipe that off too. Get it nice and clean. But we're looking pretty good. It didn't really damage the back. And it's just here. And nothing else is really messed up. So sometimes you can look at the back too and see where there's new solder, and it kind of give you an idea of work that's been done on it before. Like this chip, whatever it is, has been replaced. You can just kind of tell it looks different than the rest of them. So that is right here in the reset section. So this has something to do with the board booting up. Now see these two little box caps, they call them, these white caps here? Those are known for causing problems, so we might be swapping them too. Or is it these two? I can't remember. Maybe these two up here. I'll look into it. I think it's the box caps. Your capacitors over here, you usually don't have to mess with. But I'm going to take this battery off. I'm going to clean up this damage, and then I'll probably have to replace this chip too. But it's just a 7404. Of course, I've got those new. And then here we have a 7405. You don't see that too often. Now, whenever it's damaged the board like this, see these little black spots? That's not good. So I'm going to sand that down too, get that nice and clean, do the same thing, treat it with a little bit of vinegar. But basically it's all right here in this area. And this is pretty minor. I would say this is a 2 on a 1 to 10, and I've fixed them on this channel before that were about an 8. where parts were falling off the board, right? But this is about a 2. This isn't that bad. This board, if we messed with it a little bit, if we messed with this reset section, it may boot with it like this. But you saw how bad the connections are on the switches, so that's going to be a problem. So I'm going to start cleaning it up, and then we'll see what we end up with. Okay, so here's how it looks after cleaned up. It's looking a lot better. This connector is actually not used. Pretty good. I replaced the 2 chips, and I replaced the resistors. I didn't replace that one. Replaced the resistors, cleaned up the traces. Everything's cool. It's all good. Okay, I didn't put the battery back on it yet. I'm going to put like a remote battery holder, but we still have to test a bunch of stuff. We still have a lot to work on the machine, so I'm not going to worry about that yet. Now, it does use a 5101 for the memory, so the Bally's use the same chip. So if you can get an NVRAM solution that works with 5101s, that would work on this as well. So I went ahead and replaced the 2 reset capacitors. I looked it up. It's these 0.1 microfarad capacitors here. Little box caps. A lot of times, if you've got a problem with the board booting up, your problem comes down to this chip, which is a... if I can even read it. 4528 BPC. It's a 4528 BPC, people. You ought to know that. There you go. But someone's already replaced it. That's the one somebody replaced. And then these 2 transistors are MPS A70s. Sometimes they give you trouble. And then those box capacitors are 0.1 microfarad. And sometimes they give you problems. So, that chip's already been replaced. MPS A70s I don't have. I got to order some of those. But I did have the capacitors, so I swapped them. And the capacitor, you know, is probably the most likely to go bad, actually. Okay, so the way these things work is they use a little prom. Now, these proms just have little tiny files on them. So it's just a little bit of information that basically these spider chips, some of them have game code in them, but it's a generic game code that like how the test menu works and all that kind of stuff. It's actually in the spider chips, right? But this prom is basically just a set of selections, basically. There's not much information in there. It's such a small... here, I'll give you the part number. Let me give you the part number, and then you can figure it out yourself. What's that say? 635I-6351-IJ or something like that. The 7836 would be the date code. The G is Gottlieb's designation for the different proms. So there's different ones depending on the machine. Some of the machines use the same prom. But basically, it's just to tell the code that's already in. I don't know which chips it's in. Maybe these 2. But it's the code to tell the spider chips. It's like selections. It's almost like dip switches, right? So there's not much information in there. So it might tell it, hey, this game has 2 pop bumpers and a kick-out hole or something, something like that, right? And then on another game it says, hey, this game has 3 sets of drop targets or whatever, right? So it's just simple little switches basically for the code that's already in the spider chips. Now the spider chips themselves, a lot of them don't have the numbers on them anymore, but I'll show you the ones that I can. 11660EF, 10696EE, A1753CE. 10696EE. Is that the same one that's up there? It is. Right, so those two are the same. 10788EB. And then this one I know does the switches. A1752CF. So see how that one's different? A1753CE. So since that chip is specific to that position, you have to replace it with that same chip from that same position on another Gottlieb System 1 board. But the problem is the battery's always right here. So that's the chip that the battery messes up if one gets messed up by the battery. So to find one on another board is just as hard as if this one was messed up, you know. So it's hard to replace those. And then they're kind of hard to actually physically replace. Look at all those legs on it. Right? And so the board was designed by Rockwell, and at this time, Gottlieb was owned by Columbia Pictures. Right? And the display is actually, yeah, here we go. Assembled in Mexico. Interesting. So not only is that a problem, but sometimes on the battery damage, but sometimes the solenoid board, the driver board, I should say, that does the lights and the solenoids, if a solenoid locks on and it burns up the transistor, it sends the solenoid voltage back through the driver board, through the connector, and then burns up one of the spider chips on the board because the solenoid shorted, which if you don't know much about pinball machines, that happens not all the time, but fairly often. I mean, you might have every year or two a solenoid burns up. So, the thing, it was a cool design. It's very simple though. They really liked EM machines. They didn't really want to do solid state stuff. So their solid state system was very simple and basically was what they were trying to do was a digital version of EM machines. They didn't really want to push the envelope much. You know, they wanted to keep making the EM machines, so they kind of reluctantly went solid state after Williams and then Bally had already done it. So that's that. So they contracted it out to Rockwell and had them do it. Okay, so we've cleaned that up. I've messed with the reset capacitors. There's really not much more to do on it. I cleaned the prom. We kind of just need to put it back in the machine and see if it'll boot up. And then we can work on it from there. We can start testing some voltages and stuff like that if we can't get it to boot. But we'll go try it and see. It may have been as simple as those capacitors. It may have been as simple as we weren't getting a good connection on these connectors. Now, it won't boot without the switches plugged in because it needs to know that slam switch is shorted. Oh, you know what? I might be able to do the slam mod. I'll look and see if I can find that. But the connectors themselves are going to be corroded too because of the corrosion that was on the back of here. It wouldn't be just on these pins. It's going to be on the pins and the connectors too. So I need to replace those as well. Okay, so I looked over my notes on the slam switch. The way you get rid of the slam... So when the thing boots up, it looks to see if this switch is closed. The slam switch, like I talked about. And so you can actually short this capacitor on the board here, and then it won't... It basically thinks that the slam switch is closed. Right? So this cap right here, the way I usually do it, is I just short the two legs together on the back. I used a little capacitor, or one of the resistor legs from where I was swapping the resistors earlier. Okay. So now that that's shorted, we will never have a problem with the slam switch opening up and killing the game, or the game not booting because it can't see the slam switch, or whatever. So we're ready to pop it in now and see if we get any kind of action on it. Keep your fingers crossed. Alright, so I'm repinning the connectors. I'm pulling each one out. Now that's stuck in there, so you have to put something in there to bend the little tab out of the way so you can slide it back out. They make a little tool for it, but I always end up using like a dental pick or something that we use. We always use in a lot of our games. So you bend it, you can pull it out, and then you can see just how screwed up it looks. Cut it off. Put a new one on. I use these crimpers. These ratcheting style like this, basically you can squeeze them a little bit and they'll hold the tip, slide the wire in, and then squeeze it until you get it all the way done. It'll release, but it won't release until you get it all the way pulled in. So it gives you a perfect crimp every time. If you want some of those, you can get them all over the place. We've got a link to this exact pair on our website. You can get on Amazon. They're like, I think they're 20 bucks or 15 bucks or something like that. Go to our website. You can check it out, lionsarcade.com. We got a bunch of our other stuff that we use in our videos linked on there too, and t-shirts and all that stuff. Okay, so yeah, I keep these things in by like the thousands because you end up having to repin all kinds of stuff. So we're eventually going to have to repin this connector as well. But I think I'll just plug the switches in. Those look pretty decent. Those are the ones to the display. And we'll see if the thing will boot up. All right. We've got it re-pinned. And we have the jumper on the slam switch on the board. We've got the corrosion cleaned up. And we replaced the 2 reset capacitors. Let's see if she gives us anything. Now these have a delayed boot, so the proper operation is for about 5 seconds it doesn't do anything and then it'll come up. 1, 2, 3, 4, 5. That's how you do it, people. That's how you do it. She's trying to come back. One poor little light bulb. Now we don't have the driver board plugged in, so all I can do right now is make the displays work. That one's kind of bright. That one's a little dim. This one's really dim, and that one's bright. So this one, though, is working. You can just barely not see it. These can be fixed, though. This display over here, we figured out in the previous video, was making the power supply bog down and was lowering all of the voltages. So there's something going on with this display. And, you know, we've probably got issues with all of them, but it does seem to be at least booting. I don't know if we can coin it up or anything. Let's see what happens if I hit a switch. There is a test menu in it. I don't know if it'll work, but that particular switch doesn't seem to be doing anything. Where are my coin switches? A lot of times these games, they will modify them. Oh, there they are. I'm screwing around on the coin door here. Trying to get down to the coin switch to see if we can get it to add any credits. So I'm just hitting the coin switch. Okay. Now it says 72 credits, but that's probably not correct. That's probably, there's probably something going on with that display. You see how 2 of the digits are a little darker and the other one's bright. There's probably something going on with the chips that drive the displays still. But we are getting some kind of action from it. The switches are working. It thinks that it's playing a game. I wonder if I can start the game. So what happens if I hit the start button? Oh snap. I think it believes that it's playing a game. We got to take baby steps, people. Baby steps, folks. So let's say we shoot the ball and it comes around and it hits this. She's scoring, people. Some of it is scoring. All right. So we are up and running, just not very well. But that's a good little start. Okay, let's see what we need to do next. What's next? All right, so now that we've got the board booting, the next thing is to see if we can get the driver board to boot. And so this is the inner board connector. These give you all kinds of problems. So you need to go in and replace those pins too. So we got all new ones in there. You can actually buy this brand new. But I like using the old one and just replacing the pins. Right? So I went through and swapped them. Now, these are all corroded because they were on the board right there by the battery. These usually are fine. Sometimes you have to replace them too, but if these are corroded, you've got serious problems where the corrosion has traveled through the wires and you need to get a whole new one. So I can see with some people that may be an issue. But here's all our ones that we changed out. So I'm going to plug that in, and so what that's going to do is it's now going to, the board's going to boot, and then it's going to try to control through these lines and through the spider chips, the lamps and the solenoids. The switches we already did on those other two connectors, and you could see that whenever we were playing it, at least some of the switches were doing their thing. I was even able to add credits, start a game, hit switches, which must have worked because the scoring was going on. So now we're just going to see if we can get any of the Playfield lights that are controlled by the computer to come on, and any of the solenoids that are controlled by the computer to come on. Okay, so we've got it installed. And by the way, the A1 means the MPU, and A3 means the driver board. Got it installed. Let's see if she'll do anything. Remember, it takes 5 seconds to boot. She's booting, and I heard a click, click. Oh, what was that? The solenoid. Okay, now on the Playfield, notice there's no lights on. That's actually a good thing, because the lights, if they were locked on, if they were on right now, that would mean that there's something shorted on the driver board. This has no attract mode. It's such a simple game that there was no attract mode. The lights that are blinking in the back box are just blinking bulbs. They're not being controlled by the CPU. See how it's giving us trash on the display? So 0. And then that's the high score. It's just, since there's no battery installed on the board, it's coming up with trash in the memory where it thinks the high score is blank, blank, 7, blank, half of a 5, blank, blank. All right, so we got to put more credits back on it. And I've seen this before too, where it starts at 66 credits. That's it's the same problem where it's just trash in the memory. The game will still play and start like that. It'll probably clear up that score after we score something, and end the game. It'll save that as the score, and then it'll no longer say that. It'll say whatever the score is. So let's try to start it. Here we go. Nothing. It seems like maybe it's trying. Oh, you know what? I've got a ball in. Yeah, the ball's in the out hole. Don't bite me, Mr. Out hole kicker. There we go. I had to kick the ball out. So why was it doing that? It's because the ball was stuck on the switch, and apparently it was trying to make the out hole kicker kick the ball out, and it couldn't, so it was just stuck. Okay, so you see a few of the lights have came on. And that zzz that you're hearing zzz is the spinner, the Roto Target. This thing is awesome. These are such cool targets. This one here, it needs some work because it's not even landing where it's supposed to. How do we move it? Okay, if you go through the top, you get 5,000 points. It adds a bonus, and it spins the Roto Target. Yeah, so the boo. It's got some issues, but the problem is it just freewheels. So there's some kind of actuator, or rod, or something that's screwed up where it's not locking it in place. We'll get to that later. It did advance our bonus when we hit the 5,000. Of course, the flipper is working. Flippers are working. Make it plural. Spinner doesn't work. Pop bumper works. Pop bumper works. Those might need a little work. But we haven't done the playfield yet. But at least some of the driver board is working. Add bonus and spin the roto. I hate to keep trying to spin the roto because it doesn't want to spin, obviously. Very cool. Okay. So it looks like we're working, just not very well yet. 28,500 points. End of the ball. Okay, and it just sits there. So it should be trying to kick the ball out and all of that, but it's not. So we haven't done any work on the driver board yet. We just got the CPU, the MPU connected to the driver board. So it's all kind of limping along. So next thing to do is we're going to pull out the driver board, test some of the items on it, and then see what we need to do there. Of course, we haven't done any of the ground mods either. Keep that in mind. Here is the driver board. This is a perfect example of it. The thing has never been touched, never had anything done to it. It's brand new, basically. It just has however many years it was played worth of wear and tear on it. So what you want to look for is on these, you want it to have these 4 little diodes up here. There was another version without those that was in the earlier games. And if it doesn't have those protective diodes, and then there's 3 more down here, you can run into a problem where these transistors can short the MPU out, like we talked about. But this one has it, so I tested all of those. They're all fine. They usually don't go bad, though. I've tested all of these transistors. They're all fine. Now, this is the one that actually controls the out hole, where we were having a problem where it wouldn't kick the ball out. So I'm thinking with that, there may be a problem where the coil is stuck, or the wires broke, or there was a bad connection to the driver board. It could also be a bad connection on that interboard connector, because the MPU tells this to turn on this, which turns on the transistor. The coil. So it could be that. These things are dedicated. Almost all of these coils are dedicated to things that are in each machine. So there's only 3 of them that are different on each machine. I had a customer come in. Okay, so I'll show you how they did this thing. Now, I'm not criticizing it. I'm just showing you how archaic this is. Okay, this was Gottlieb's first solid statement. But like I said, it's designed by Rockwell. I think of the song every time I look at that. So the MPU sends signals down to these driver chips that control the lamps. There is an individual, I don't know if it's an SCR or what. It looks like it says MPS A13. Right? Each one of those controls one lamp. So one of there were a couple problems with the Gottlieb System 1 stuff. One is if those spider chips went bad on the MPU, you couldn't get replacement ones because they invented it or something just for the MPU. Kind of screwed us up. All of these are off-the-shelf stuff. You can get this stuff or something to substitute for it, right? but those spider chips that run it on the MPU, and some of those had code in them, so causes problems. Okay, so that was one problem. The second problem was the grounds had problems where the boards weren't properly grounded. So they figured out years later, I think it was Mr. John at flippers.com, I believe he was the one who figured it out, but they figured out that there's a ground differential between the boards after a while. You get resistance on the connectors, and then this has a ground that isn't at 0. Maybe it's at 0.3, and the other one's at 0, and it causes problems where stuff starts locking up and things. So some of the solenoids would lock on and things like that. And on the earlier boards that didn't have these diodes, it would send voltage back through and fry the MPU. So that's problems, right? But one of the other problems that it had was that it was limited, very limited. So there's only a certain number of these little lights that it can actually turn on. And then there's only a certain number of the bigger transistors to turn on coils. So, like I was saying a second ago, these were dedicated, most of these were dedicated to stuff that was in every game, so you didn't really have the opportunity to fiddle around with it too much. So on say like a Williams driver board, which actually came out before this, Williams hit the road with their system before Gottlieb did. I think this one is the knocker. So each game has a knocker in it, so that transistor is always used for the knocker. This one was used for the coil that makes the 10-point sound, 100-point, 1,000-point. So you have 3 of them. One's used for the knocker, and then 3 more that are used for the coils for the chimes. So all of these are the same on each game and can't be used for anything else if you're designing it, if you're the designer of the game. Okay? Now, on this particular game, there's a soundboard, and they just send the signal for the chimes to the soundboard. The soundboard uses it to make beeps and boops. We will be looking at that soon, right? But if you're designing the game, you now have 4 of these that can't be used. Now, on the Williams board, there was also a transistor that always pretty much did the knocker, and then there were 5 solenoids that sent 5 different sound lines to the soundboard. I don't think even the first Williams solid state games had chimes still in them. I think the first one had a soundboard, but I may be wrong about that. But there were 5 lines, so there were more, and so whenever they made their soundboard, it could be more complex because they had 5 different control lines, and then also you could turn on, like, say, 2 of those to give you a 6th one, and then 2 other ones to give you a 7th one, and so you could make like 25 different, or something like that, sound requests, basically, using the solenoid drives. Okay? Remember, these ground the power that's coming back, so it's all complex, but you get what I'm saying. So the Williams one was just more advanced, is what I'm saying. And so over here you have these smaller ones. These are MPS MPS U45s. Okay, so they're not quite as powerful. So these are, one of these does like the game over relay, because Gottlieb chose to continue using relays in the system. So they wanted to keep their game over relay and their tilt relay. We're running out of transistors here that we can do coils with, people. Okay. And then they used one of them for the high score to date light. I don't know why they had to use the bigger transistor for that, but I think it's because they were planning on turning it on and off and making it blink. So for whatever reason, they couldn't use one of these for it. They had to use the bigger transistor for it. And then they did the same thing with the shoot again light. I have no clue why that is, but this one does shoot again. This one does high score to date. One of these does the game over relay. One of them does the tilt relay. So all of those are used. So, oh man, now we're down to just these. Okay. Well, this one's the out hole. So you can't use that one either. Every game has an out hole. So if you're the designer of the game, you have 1, 2, and then this. You have 3 solenoids that you can actually change and make specific to the game. This one is just a pre-driver for this bigger 2N3055. So they only had 3 solenoids that they could actually make different in this game or this game or this game as a designer. So in this particular game, this pre-driver and this big 2N3055, they drive the drop target reset. And this one drives the Roto Target that spins around. And this one, they didn't use for anything. So they had 3 and they only used 2. Just interesting. So the whole point is all of these have to be something that the computer can control, okay? So there are other coils. So there's 2 flippers, for instance, but the computer cannot turn the flippers on. You hit the flipper button on the side of the cabinet, and that makes the flipper work. Well, how do they make it where you can't hit the flipper while the game's sitting there? With the game over relay. So when the game is in game over, one of these turns on the game over relay, which pulls in and, or I think actually it turns off the game over relay whenever the game's on or something, you know, but either way, it controls if the game over relay is on or off, which controls whether or not you can use the flippers. Okay, the tilt relay, what it does is kill the lights, so the game looks tilted. Just weird. So there's that, and then the pop bumpers. They could put 100 pop bumpers on the playfield if they want, because the ball hits the little the skirt and makes the pop bumper move itself. The CPU has no way of turning on the pop bumpers because they don't have enough. It's just not complex enough. And then the kickers. Down by the flippers, the ball kicks around, and they could add 4 or 5 of them because it's just a switch, and whenever you hit it, it makes the coil come on. But the computer has no way of controlling the kickers. So on the Williams boards, they had something like 25 transistors or something like that, so they could control all kinds of stuff from the CPU. And then they had that other section that weren't there like special solenoids as well? That may have been not till System 11, but the Williams driver board was much more advanced, right? So, but this is what Gottlieb got away with. Now, these driver boards are pretty reliable because there's not much to them, you know. So, like I tested on this one, I couldn't find one thing wrong with it. All of these transistors test fine. I'm just comparing them with a diode check to each other. So, you know, you put the one, use the diode check on your meter, put one leg on the middle, and then see what the readings are of the other 2 legs, and then test this one and see if it's similar. It doesn't have to be exact. They all seem fine. Same with these. Okay, and the 2N3055 seems fine. Nothing even seems burnt. A lot of times this one will look all cooked where it like heated up the board. But if you look, I don't see that at all. I mean, if I didn't know better, and I really don't, I'd say this thing's new old stock. I mean, it doesn't look like it's ever been used. There's no damage. Nothing's been repaired. I cleaned off the edge connectors. There's no damage. Nothing's ever been done to it. Looks like a brand new board. Very cool. So it says inspected by a bunch of people. So we're probably the first people to inspect it again since these people scribbled on it. Okay, so you can do the ground mods too. So basically the way they overcome the problem with the grounds being different on all the boards is that you add an external ground wire to it. So if you put a ground wire right here on the bottom of this cap, you're basically grounding all of the ICs to that wire, because the bottom of that cap connects to all of those. And then you run a wire off and attach it to a central screw somewhere on the back box. And then you run one from the power supply, same thing, put it on the ground of the big filter cap on the power supply, run it to the same screw, and then you put one on the ground of the MPU, on the little capacitor on the MPU, and you run it to the same spot. So basically you're tying all 3 of the grounds together. So the boards always have the same exact ground potential, basically. And that basically makes it where the games don't lock up. They don't. The problem is if the CPU stops controlling the spider chips on the MPU, if the code crashes, it can allow them to lock on coils and stuff on the driver board, which will burn up coils in the game. And it was a problem that Gottlieb still had on their System 80 games, and then later had on the System 3 games too. So they just had ground problems the whole time. But this board seems pretty good. We're going to do all of the ground mods, but we're going to do them later. So eventually we'll put another wire on there, but not right now. So I'm going to put this back in, and I'm trying to figure out why the out hole coil is not working. There's hopefully, there's a wire loose or something. So this is the coil that kicks the ball out. Strangely, to me at least, it has its own fuse. I don't know why you'd put a fuse on just one coil, but there must be a good reason. So the fuse was blown. Now, why would the fuse blow? They usually blow for a reason. If you check the resistance of the coil, though, it's 11.4 ohms. Now, anything below 2 ohms or so usually means that the coil is burned up. And usually it'll look like it's burned up. But this one looks fine. So I don't know. Why did it blow the fuse? Maybe it got locked on because the board screwed up. You saw the acid damage and stuff, or the alkaline damage. Okay, so while I'm under here, I'm going to go ahead and swap the bulbs, right? And I'm going to clean the dirt off of the contacts on the switches. And that will leave us with coil-wise. We've got this Roto Target, just roto spins. It shouldn't do that. Something's come loose or something there. But we're getting there. Okay, folks, so the speaker was unplugged too. I plugged the speaker back in and it's popping a little bit, crackling. It's trying to come back to life, people. But we got an issue where we can't go into the test mode yet. So I think there's still some switch problems. But watch this. We're going to put some credits on it again. And we're going to start it, see what happens. Alright, so the out-hole kicker is working. I believe I saw it try to reset the drop targets. The Roto Target is not working yet. This thing is really cool because it spins around and gives you different values, which you can then score if you hit them. So that should be 300 right now, but since it's not landing where it's supposed to, I think there's issues. So that's not scoring. See that gloom? That was it trying to spin it again. We're getting some things scoring, but we're not getting any sound whenever it scores. And the spinner does not work. Now, this is after I cleaned it, too, right? The spinner doesn't work. None of the drop targets work. So it's not scoring any of those. And we can't get into tests to get all the lights to come on, so we don't know about that yet. So, spinner's not working, 5 drop targets aren't working, and the test switch isn't working. When you have a lot of switches working, this works off a switch matrix, so there's these lines that are shared by different switches, and I'll bet that all of those are on the same line on the matrix. So we've got one of these switch lines isn't working now. If that ends up being the spider chip, glunk, 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 that's the end of it. That's all she wrote. We'll have to buy a new board. But there are some other chips in that area that it could be too, or it could just be a broken wire or something too. But we'll have to mess with that next time. This video is getting long in the tooth. So make sure to leave your comments below. Let us know what you think so far. Give us a thumbs up for taking the trouble to film it for you. Hope you've enjoyed it. We've at least got it back doing its thing. I don't want to play it too much because the playfield's so filthy. But, and you know, of course, we still need to work on the displays as well. Boy, it has a real delayed ball kick out. display's got the wrong number on it. Kind of works. By the way, I was talking about the kickers earlier. I forgot on this one there's only one kicker. This isn't a kicker. But I don't want to roll the ball over the playfield too much while it's got all that dust and dirt on it. That's the end of the game. So it worked pretty decent. Unknown caller. They're spam calling me again. Let's see who that is. All right, nothing important. Okay, so we still got a lot to do to it, but I think what I want to do next is get the playfield cleaned up so that we can play it a little bit, and then we can do the final troubleshooting, fix the displays. By the way, don't worry about the dim displays. That's easily repairable. We'll do that in a later video. But I think it's getting there. So I hope you enjoyed it. Leave your comments below. Let us know what you think. And make sure to check out my brother Donnie. If you don't know about that, we have another channel. It's my brother's channel. We work on these old pinball machines. He works on old buildings. We've got a couple buildings that we bought in a small town near here that are down in the downtown area that are, whenever we bought them, they were dilapidated, and we're fixing them up, trying to rent them out. Pretty cool. Historic buildings. And he also likes to work on cars. So I'm over there with him a lot of times working on old pickup trucks and stuff like that. So if that sounds interesting to you, go check out my brother Donnie. But we will see you on the next video where I think we'll work on the playfield next.